So systems of equations, or nonlinear systems, which is what we're doing, where they intersect is your solution. Okay? So if they intersect, we say that it's consistent or that it has a solution. If it doesn't, then we say it's inconsistent. Those are just random words for you. Okay? So consistent has a solution, inconsistent doesn't have a solution. So we have a quadratic and we have a line. And when you're graphing a quadratic and a line, there's a couple of things they can look like. Okay? They can never touch. All right? They can touch once or they can touch twice. Okay? So what we're going to look at is what's going to happen when we graph these. So as far as the line part, the like negative x minus 8, we should be good graphing that right off the top. Like, let's just get the line on there, and then we'll talk about how we're going to do the quadratic kind of quick. Okay? So negative x minus 8. I've got a y-intercept at negative 8 and a slope of negative 1. So you're going down 1, out 1, down 1, out 1. So make sure you graph it correctly or the whole thing just starts off wrong. Okay? So negative x minus 8. In that quadratic there, the negative 4 at the end, that's your y-intercept. Okay? So no matter, like, this one's negative 4, this one's 27. On the other pages, there's other numbers too. Like that one's negative 1. Okay? So that y-intercept is always this last number over here. Okay? So negative 4. Okay. So we haven't, well, there's more to what I'm going to tell you, but we're just going to look at a part of it right now. So that 4x right there. Okay? 4x. When a is 1, okay, when the number in front of x squared is 1, we're going to divide this by negative 2. Okay? Divide 4 by negative 2. When you divide 4 by negative 2, what do you get? Negative 2. So I'm going to make a table to graph this, and negative 2 is going to be the first number that I use to graph it. So I've got x squared plus 4x minus 4, and then we'll get a y out. Okay, so first x is going to be negative 2. Okay. So I've got negative 2 squared plus 4 times negative 2 minus 4. Okay. So I've got negative 4 minus 8. Or 4 minus 8 is what? Come on. 4 minus 8, negative 4. Take away 4 more. We're at negative 8. Okay? So when x is negative 2, y is negative 8. So negative 2, negative 8. Okay? I want to try to get closer to my line. So closer to the line, is that going to be negative 1 or is that going to be negative 3? Get closer to my line. Huh? If I want this point to get closer, would I go this way or would I go this way? Left or right? To the right. Okay, so that would be negative 1. So we're going to plug in negative 1. So negative 1 squared plus 4 times negative 1 minus 4. So I get 1 minus 4 minus 4. So 1 minus 4, negative 3, minus 4, negative 7. So my next point is at 1, negative 7. So if you think about a quadratic, it's going out 1, up 1, and then it went out 2 and up 4. So this is our parabola right here. Okay, it went out 1, up 1, out 2, up 4. So I have one of my intersections. If I plug in -3, what number do you think I'm going to get back out? If I plug in -3, we're going to get out -7. Or not -3. Yeah, -3. So -3 squared. So that's 9 plus 4 times -3. 9 minus 12, you get -3. Minus 4, you get -7. So when I kept telling you, if you just remember the parent function points, it'll make everything a lot faster. This is where it makes it a lot faster. So there, I've got 2 intersection points. Okay? So my solutions, or where they intersect, is at -4, -4, and at -1, -7. So if you do this graphically, where your intersections are your solutions. Okay? So we figured out what the y-intercept was. We divided that middle number by -2, and then we just started plugging points in around that. You got questions on what I did here? No? Because when you're going from standard form, which is what this is, to vertex form, there's this thing that you use. It's called minus b over 2a and then f of minus b over 2a. So this is just the -2 part, since we're not actually doing the whole quadratic yet. For the 12? Yeah. You're going to do that every time.